So when we are looking to add and subtract square roots, radicals, it's all about like terms, like everything else. But what in the heck is a like term for radicals? Well, it's a matching radical, the same number underneath the square roots. So you're looking for the number under the radical be the same. If that's the case, the outside numbers are the parts that combine. So the outside parts, the outside numbers are the parts that will combine. So in this first example, we see the radicals match. We have root 6 here and here. Those are matching radicals because they have the same number underneath the radical sign. So we're going to do our combination with the outside numbers, the math with the outside numbers here. 3 plus negative 4, or 3 minus 4. What does that make? Negative 1. What we still have is root 6. So it's a lot like looking at 3x minus 4x. It's very similar. Instead of x's, it's roots, matching roots. So you write it like that, or you could write it like just a negative sign on the outside, negative root 6. Either of those are good. Here's another example of matching radicals, like terms. These are like terms because the 7 is the same under both the radicals there. Got the same root 7, so our answer will have root 7. And then we combine the outside numbers. Negative 10 plus 12 is 2. So 2 root 7 is that answer there. All right, here's another example here. We have matching radicals once more. They're both the same because of the root 5. So our answer will be some sort of term of root 5. And we're going to look at these outside numbers, but there's a missing number. There's no number in the first one. What is this missing number out here? 0. It's a 1. If it was 0, it would be equal to 0. It has to be a 1, an invisible 1. So that 1 plus negative 4 is negative 3. So negative 3 root 5 for that answer. Can I simplify this one? No, this is non-simplifiable because these roots don't match. We have unlike roots. One is 3, one is 5. We cannot simplify this. So you would leave it just as is. Alright, so sometimes we can't simplify like we saw above. Those roots don't match. And we can't even simplify them to make them match. Because that's what we're going to do. We're going to try to make them match sometimes by simplifying. So in this example here, we have negative 2 root 3 plus root 27. So let me zoom in. So obviously we know that these don't match, but we're going to try to simplify one of them to make a match. 3 is already simplified, but we can find a perfect square factor that goes into 27. Look at the digits. 2 plus 7 is 9, so 9 will fit into it. So our perfect square of 9 times 3. So the square root of 9 will now break out a 3 on the outside, and now root 27 becomes 3 root 3, which will now match with the other term. Now we have matching roots. We're going to do our math with the front numbers. Negative 2 plus 3 is 1. So our answer will be 1 root 3 or just root 3. All right, here's another example of us trying to add, subtract roots that don't match right away. They are different numbers, but we are going to break down 24. Can't break down 6, but we can break down 24 and see if the root will match. So our perfect square that fit into 24 will be 4 times 6, the non-perfect square. Sometimes these problems are set up to get the same root eventually. So if you look at this over here, root 6, that could give you a hint that this needs to be a root 6 eventually. And that can go, oh, okay, 6 times 4, and there's my perfect square. So the square root of 4 is a 2 on the outside, but don't forget to multiply with this other negative 2 there. So negative 2 times 2 makes that term become negative 4 root 6. So again, the second term here is simplified to negative 4 root 6. Now we're going to just drop down 2 root 6 and combine our like terms. 2 root 6 minus 4 root 6. That negative is part of this whole thing there. So we're going to do 2 minus 4 to get negative 2 root 6 for that answer. All right, for this last one, the pattern 1 practice here, we can't simplify root 2. Okay, but now we go to the next term, we look at root 20, and there's a perfect square that fits in root 20. Once again, we're breaking down root 20 with root 4 and root 5. Our square root of 4, 2 comes out on the outside and multiply with the 3 that's already out there. So that middle term becomes 3 times 2 is 6. 6 root 5. I'm going to write this down here. So that will be, I said 6 root 5. I couldn't simplify this. Go ahead and put that down here. So negative 3 root 2 plus 6 root 5. I can't combine those. They're not like terms. But maybe this one will give me one. So we break down the 8 with 2 times our perfect square of 4. Square root of 4 becomes a 2 on the outside. That will multiply with this negative 3. So negative 3 times 2 is negative 6. And the square root of 2 is there. So now we do have matching terms. We have root 2's that match, the first term and the last term. So those are our matching terms, root 2, root 2. We're going to add the outside numbers. Negative 3 plus negative 6 is negative 9. So negative 9 root 2. And what we still have up there is the 6 root 5. Nothing can combine with it. So that's our simplified answer. May the math be with you.